Hello, statistics student. This video is for chapter 10.3. We are doing a hypothesis test for two proportion from two different populations, and we're doing example 1. So we are done with the using a statist to find p-value and test statistics, and we find that the test statistic is 7.11. That means the difference in size of the two sample, one being 11%, one being 1% compared to 0% in x0. So that's the reason why we call them x0 is because it's zero like assumed to be not to be exactly the same. Your sample is like 7 tick mark away. We know that 3 tick mark is already like 0% chance of happening. So this would be a 0% chance of sample. So you reject 0. And because in the beginning we say we are comparing our claim is they're the same. So you can clearly see that the claim is x0. So in your conclusion, you have to use the word reject, because you should reject x0. And of course, if you reject 0, you reject the claim. So I have the conclusion also open. So we can also say that, okay, x0 is the claim, so we stop here. And then we just reject 0. So we say there is sufficient evidence to reject the claim, right? Box number 1. So in this particular case, over here. And then we move over to the other side. We say here. So we say that we conclude that there is sufficient evidence to reject the claim that proportion of cars with rare license plate only are the same that of New York. So sufficient evidence to reject the claim. You are rejecting that they're the same. That means they're not the same, right? Look carefully. You are sufficient to reject that they're the same. You say, I have evidence to say that you're not the same because you're like 7 tick mark away. So you must, to say that you are 0 is not very good. So claim is not true, right? And also you can see that whenever you have such a low p-value, samples are not the same. Samples, the sample, the fact that the sample difference are so big indicate that proportion are not the same. Proportion is difference. Proportions are difference. They are not the same because you have a very, very low p-value. Okay, so and then in the output, you can also see that this shows up. I'm going to show you. No, it's in the this output here. You see 7.1 and then total 0. For test statistic, you usually run it to 2 places, so we say 7.11. P-value 4 places. We also have a 95 confidence interval at the end. So it's 0.83, 0.118 after rounding. So you see how I write it down, 0.083, P1 minus P2. So P1 minus P2 is the difference. So how big is the difference? Our sample shows that they are 1% to 11%, right? What is that? What is it? What is it that we say? Okay, 11% and 1%, so around 10% difference in the sample. But actually, the population difference are how big? It could be 8% difference to 11.8% difference at 95 confidence level. So this is how we write down. We concluded the difference is between 8.3% to 11% at a confidence level of 95%. So how do they get this 95? Because they use 1 minus a significant level. So that would be, this is 100% and minus 5%. So that's why we have 95%. You can also look at the fact that this is a positive. So if they're difference, which one is higher? Population one is higher. So positive. The whole interval is positive. That means whenever you subtract P1 and P2 is positive. So P1 is greater than P2. The one in Connecticut has a higher percentage of rare license plate car than those in New York. Okay, And also this example shows you that if you want to find n, sometimes they don't give you 2049, they give you these two numbers, sometimes you have to add them. Okay, so the second example is someone set an experiment to test the effectiveness of aspirin in preventing heart disease. So they want to see if people take aspirin, which is just a painkiller, can it actually help to prevent heart disease or lower heart disease outbreak? So they have 11,037 adults take aspirin, and it's a lot of samples, right? Large sample. Another 11,034 adults given a placebo. And then afterward, they find that the one in the treatment groups, 1.26% experienced heart attack. In the placebo group, in the control group, 2.17% experienced heart attack. So you can look at this, unlike the last percentage that we compare, 11 to 1%, that seems to be really big. This is really small. So does it mean that aspirin has no use in lowering a heart attack? Like I don't think it can prevent, but lowering heart attack rate, right? So we would use the hypothesis test to compare. So what happened is we only have, so when we do the hypothesis test, remember we have to do N1, X1, right? But here I don't have X1. I only know that in that percentage, 1.26 has heart attack. So what we can do is make use of the fact that P hat is equal to X over N. So if I don't have X, X is P hat times N. Just like I think we talked about that before. But before we do that, we also need to define population 1 and 2. And in the question, they talks about the aspirin group first. So we'll just treat it as population 1, the treatment group. And 1 is 11,037 patient. X1 would be 0.0126 times 11,037. If you multiply them, you make sure that you give the rounded whole number, 0.0126 times 11037. So it is actually 139.06. So you round it to the whole number of 139. There's similarly for the placebo group, the control group, and 2 and X2. X2 you have to calculate 0.0217 times 11034. So it is actually 239.4. So you round it to a whole number of 239. Okay. It was 239.4, but you round it to whole number. Okay. Both of them you round it to whole number. And then what is our claim? Our claim said that it is effective to lower heart attack, right? Aspirin is effective. So that means the treatment group would have a lower number. So P1 less than P2 is our claim. X0 when we are comparing two population parameter is always they are equal. P1 is equal to P2. And the alternative would be the claim itself, so that I know that the claim is here. I want to support this claim. Okay, because right now the claim is in alternative. So when we do conclusion, remember your statement would be about support if you have sufficient evidence, right? So then you write down your significant level. You have to make sure that you are doing a left tail test because it's pointing to the left side and it's C distribution. And then you just do the same thing as in example 1 because we're still doing the same thing, right? Write this down first. Don't remember. 11037 and then 139. Then 11034 239. So one is 139, the other is 239. Yeah, interesting. So then we do that this is still 0.05. The first one is 11037 is the aspirin group and it's 139. Then the other one was 11034, 34, and is 239. There are more people, but in terms of percentage, they're quite close. What happened? Well, actually, because the sample size is so big, the test statistic is -5. Sample 1 is lower by up to the point of 5 tick mark. And then the p-value is still 0, and we have this confidence interval, -0.012, -0.006. So we write this down, all these results, test statistics, p-value. So there's a lot of things, but we are only, oh no, I think I forgot about the fact that I'm doing a left tail test. This always happen. Left tail test is a lower one of the value. Okay, so this is still okay. -5.1, still -5.19, still 0, but the p-value is 0.0012 and 0.006. Yeah. So remember it's less than. Earlier I didn't do less than, but it seems like it's the same. I think it's because it's very extreme. So then it is obviously a rare sample. We have to reject 0. If you reject 0, that means it does not match with the assumption of it being the difference being 0, right? Although they are 1% and 2%, because of the big sample size, this is 0. Your 1% is actually all the way to 5 tick mark below. 1, 2, 3, 4, 5. Of course, there's no way of happening. It is really a really low one. So then we say reject 0. This is the conclusion. There is significant difference. If you reject 0, there is significant difference between them. But is it lower? If it's higher, you can be significant difference also. And we use the support statement. So let's see what we can do. We would say, and because we reject 0, the claim is in HA. Use sufficient evidence. So this is the final wording. There is sufficient evidence to support, right? Use the support statement because the claim is in X0, that aspirin is effective in lowering heart attack. So when you say the claim, you don't say that whatever is higher than whatever. You actually just say the claim. Effective means aspirin can have a lower heart attack rate for people. And we can also look at the, here, we should also look at the final conclusion. Our claim is in HA, right, because it's lower, and we reject the null hypothesis, so we say the sample data support the claim. So there is sufficient evidence to support the claim that aspirin is effective. And then we also write down our confidence C level. C level is 90%, is it? Let's look at, yes, it's 90%. How come? How come it's not 95%? Because you're doing a left tail test. So the equivalent one is you have a 0.05 on one side and a 0.05 on the other side. So 90% is, so that's how they calculate it. But they calculate for you. So it is 0.012 negative and also 0.006 negatives. So it's 1.2% to 0.6%. So they are different, but the difference is really small. And because both of them are negative, you can conclude what? Which one is larger, which one is smaller? The whole interval is negative. That means this must be smaller. So imply P1 is less than P2. You have a low number, subtract a big number. So the whole interval, so P1 is less than P2. That means people that take the aspirin has a lower heart attack rate than people that do not take the aspirin. This is placebo. So they do have lower attack rate. So that's why it's effective. Then based on this, we would say that they're both effective. What happens if the sample is not a good sample? If they are not good sample, then it may not work. Okay, so you have to make sure that the sample is okay first.